So in last lab, we performed the experiment of the multiplexer and demultiplexer. So let me share my screen. Which is our experiment number 7 actually. So again, so again we are performing the experiment in the virtual lab. So move to the list of experiment. So let's see, the first experiment is the verification and the interpretation of the basic logic gates. So that basic logic gates you can say AND or NOT. NAND and NOR we already covered. Or you can say the second one is the half adder, full adder, half subtractor, and the full subtractor. So that's also we covered. The third, the next experiment is to study and verify the half and the full subtractor. It's also already covered. Then the realization of logic functions with the help of universal gates. And so there are two gates which is known as the universal gate. As we know, it is a NAND gate and the NOR gate. Then we have studied about the comparator. So it is we having a 1-bit comparator and 2-bit comparators using logic gates. Okay. So it's already covered, and then we start the experiment of the which is experiment number 9 in our virtual lab, implementation of 4x1 multiplexer and 1x4 demultiplexer. So in last lab we performed the experiment of the multiplexer and the demultiplexer. We performed the experiment of the multiplexer and demultiplexer. So today we have to perform the experiment of the implementation and verification of the decoder and encoder. Here in the experiment we are not learn about the demultiplexer. So we have to focus on the encoders and decoders only. We have to focus on the encoder and decoder only. Okay. So this is our experiment. The aim of the experiment is to analyze the truth table of 4x2 decoder. Here we are learn about the decoder only. So the experiment is to analyze the truth table of the 4x2 decoder using NOT AND gate and 2x4 encoder. So we have to learn about the 4x2 decoder and 2x4 encoder. In this experiment. So we have to focus about the encoders and decoders. And again, the simulation is the same thing. If your truth table is right, then the LED will glow. Otherwise, the LED will not work. Okay, so we have to verify the truth table of the 4x2 decoder and 2x4 encoder. So we have to learn about the encoder and decoders first. We have to learn about the encoder and decoder first. Okay. So let's move for the theory session. So again, we have to learn what is actually encoder and what is actually decoder. Okay. So encoder and decoder. So again, the encoder and decoder is the combinational circuit. Okay. Encoder and decoder is the combinational circuit. But what is the application of encoder and decoder that we have to learn? What is the application of the encoder and decoder that we have to learn? So first we cover the theory portion, then we will move for the pre-test, and after the pre-test there is the simulation. Okay. So what is decoder actually? If you know the meaning of decoder, the meaning of decoder is decode. Suppose you have some code, and if you want to decode that code, then you require the decoder. Let me show you the again. The encoder and decoder is already covered in the theory session. So I think almost all of you are aware about the encoders and decoders. Okay, so let's say this is the decoder. Now, what is the decoder? Okay, so again, the decoder is the circuit which accepts the set of input. So encoder and decoder is the different than the multiplexer and demultiplexer. Encoder and decoder is the different than the multiplexer and demultiplexer. If you remember, in multiplexer we have n numbers of input. We have n numbers of input, but only single output. N numbers of input, but single output. And in demultiplexer, we have only single input. We have only single input, but numbers of outputs we have. But numbers of outputs we have. Okay. But here in encoder and decoder, we have numbers of input and we have numbers of output, and it is depend on which type of encoder or which type of decoder you are using. Okay, which type of encoder and which type of decoder you are using. So we have m numbers of input and we have n numbers of output. So decoder, what is the meaning of decoder? The input of decoder is something a code. Either the input of the decoder is binary code, or you can say the input of the decoder is the BCD code, or the input of the decoder is the XST code. So input of the decoder is code, and what decoder does, it checks the code and gives the output and it decodes the code. Suppose I have an input 3-bit binary code. 3-bit binary code. So as the input of the decoder, it having some code. Okay, as the input of the decoder, it having some code. So what decoder does, it decodes the code. It decodes the code and checks that and converts that code into a either you can say in octal or you can say in a decimal. Okay. So the application of the decoder is decode the code and give the answer in the known numbers. You can say a decimal number or alphabetic characters. Okay, so that is the main application of the decoder. That is the main application of the decoder. You can see here a decoder is a logic circuit that accepts a sets of input, that accept the set of inputs which represents a binary number. Okay, which represents the binary number, and it will give the output when regarding to the our input number. Suppose my input is 001. Our input is 001, so we have 8 outputs: 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so what is the meaning of 001 for 001? If you convert into octal for 001, it is 1. So at a time, any one input will be activated. At a time, only one input will be activated. So that is the main application of the decoders. Okay. You can see here what does the decoder do. So a decoder circuit looks at its input and it determines which binary number is present there. So because the input of the decoder is a code. So suppose we have a binary code. Suppose we have a binary code as an input. Okay. And activates the specific output. Suppose we have numbers of output there. Suppose we have numbers of output there. So the decoder activates the specific output which is corresponding to the input number, which is corresponding to the input number. And all the other outputs is remain inactive. All the other output is it's remain inactive. Okay. So that is the main application of the decoder. That is the main application of the decoder. In a general form, decoder has n numbers of input line and also m numbers of output line. And only one output line at a time. Only one output line is activated. At a time, only one output line is activated for each one of the possible combination of input. So for the input possible combination, at a time only one output line, at a time only one output line is activated. At a time only one output line is activated. So this is the general figure of a decoder which having a numbers of input and numbers of output. So you can say n numbers of input and m numbers of output. So in experiment we have to learn about the 2 to 4 line decoder. Here we have a 3 to 8 line decoder. So as the input we have 3 lines and as the output we have 8 possibilities. Let me draw the block diagram of 3 to 8 line and then we will move for the 2 to 4 line. Okay, so suppose you can see it is a 3 cross 8 decoder. It is 3 cross 8 decoder. So it having a 3 input line. It's having a 3 input line. You can say this is my input line. You can say it is I2, I1 and I0. I0, I1 and I2. So this is my 3 input line, I0, I1 and I2. I is indicated for the, I is indicating for the input, I is indicating for the input. Okay, and we have 8 output lines. You can say it is O0, O1, O2, O3. So you can see this is our output. Okay, this is our output. And output is starting from the O0, O1, O2, O3, O4, O5, O6, and O7. And O is indicating for the output. So suppose my input you can say is 110. So this is a code. This code is as my input. This code is as my input. So 110. So if you convert 110 into decimal, you can easily understand it is 6. So only O6 output will be activated. Only O6 output will be activated. All other 7 outputs starting from O0, O1, O2, O3, O4, O5, and O7 is inactive. So that's how actually 3 cross 8 decoder will be work. That's how actually 3 cross 8 decoder will be work. So you can see in the table when our input is 0, 0, 0. Only D0 output is activated. Only D0 output is activated. All the others output is inactive. All the others output is inactive. For 0, 0, 1, the D1 is activated. All others are 0. You can see in the table also. For 0, 1, 0, only D2 will be activated. All others are 0. For 0, 1, 1, only D3 output will be activated. All others 0. For 1, 0, 0, only D4 output will be activated. All others 0. For 1, 1, 0, only D6 output will be activated. All others are 0. And for 1, 1, 1 or triple 1, only D7 output will be activated. Only D7 output will be activated. All others output will be 0. All others output will be 0. Okay. So this is the truth table of the 3-line to 8-line decoder. This is the truth table of the 3-line to 8-line decoder, and you can also say that it is the truth table of the 3-line to 8-line decoder. So from that truth table, we have to draw the figure. So this is the logic diagram. This is the logic diagram of the 3 cross 8 decoder, 3 cross 8 decoder, or you can say 3-line to 8-line decoder. This is the truth table of the 3-line to 8-line decoder. If you remember the truth table, the output equation of D0, the output equation of D0 is A bar, B bar, C bar. The output equation of D0 is A bar, B bar, C bar. From the equation you can see. See, for 0, 0, 0, my output D0 is only activated. For D0, the output is only one time, and at that moment my input is 0, 0, 0. And here we have to focus on the SOP form. So 0 means bar, 1 means as it is. So here equation is A bar, B bar, C bar. It is already written. Again, D1 is activated only single time, and at that moment my input is 0, 0, 1. At that moment my input is 0, 0, 1. So A0, B0, C1. So A bar, B bar, C. So you can see that number. Also D2 is activated only single time when the input is 0, 1, 0. When the input is 0, 1, 0. So when the input is 0, 1, 0, so A0, B1, C0, A0, B1, C0. So what that means? A bar, B, C bar, A bar, B, C bar. Same way you have to check the outputs of each and every one when the output will be 1. And when the output will be 1, you have to check its input possibility. You have to check its input possibility and what is the input? What is the input at that time? From that you can write the equation. From that you can write the equation. So that equation only we are implementing. That equation only we are implementing. Okay. So for D7, the equation is ABC. So we have two lines. The first line for A, another for F dash. Again, we have the line for B bar, C, and C bar. You can see here. Okay, so A bar, B bar, and C bar. A bar, B bar, and C bar. So from that we are drawing the equation. From that we are drawing the logic diagram. So this is the logic diagram of the 3-line to 8-line decoder. This is the logic diagram of the 3-line to 8-line decoder. Okay. Now we have to focus on the in experiment we have to learn about the 2-line to 4-line decoder. We have to learn 2-line to 4-line decoder. Okay. So we have to learn about the 2-line to 4-line decoder, 2-line to 4-line decoder. So suppose we have let me draw the first truth table. So suppose we have two inputs. Which is A and B. Suppose we have two inputs A and B and we have a 4 output, you can say O0 or instead of 4 let me write down D. D0, D1, D2 and D3. Okay, so we have a equation 2 input 0 0 A and B and we have 4 output, you can say D0, D1, D2 and D3. So when my input is 0 0, only D0 will be activated, all others are remaining 0. All others are remaining 0. When my input is 0 1, only D1 is activated, all others are remaining 0. All others are remaining 0. Suppose my input is 1 0. Suppose my input is 1 0. So only D2 will be activated. All others are the 0. All others are the 0. And suppose my input is 1 1. Suppose my input is 1 1. Then only D3 will be activated. All others output will be 0. Okay. So we have to write the equation of the D0, D1, D2 and D3. We have to write the equation of the D0, D1, D2 and D3. So D0 is activated only one time, and at that moment my input is A and B 0 0. At that moment my input is A and B 0 0. So the equation of the D0 is A bar B bar. The equation of the D0 is A bar B bar. Then D1 is activated only one time, or the output of D1 is one only single time, and at that moment its input is A0 B1. So 0 means bar, and 1 means as it is. So A bar B. Again D2 is activated only one time. And at that moment the input is A1 B0. So the equation is A B bar. Equation is A B bar. Okay. And D3 is one only single time. And at that moment the input is A and B 1 1. A and B 1 1. So equation becomes AB. So the equation becomes A into B. So this is the truth table of the decoder, 2-line to 4-line decoder, and let me draw the block diagrams. It's having a 2 input, you can say A and B, and it's having a 4 output. And that 4 output is D0, D1, D2 and D3. That 4 output is D0, D1, D2 and D3. So this is the block diagram of a 2-line to 4-line decoder. This is the block diagram of the 2-line to 4-line decoder. Okay, so now we have to draw the logic diagram. Okay, so let's draw the logic diagram of a 2-line to, let's draw the logic diagram of the 2-line to 4-line decoder. So again, it having 2 output, you can say, let me draw the logic diagram. You can say it is A and B. Okay. So the equation of let me say D1. Sorry, starting with D0, or you can say starting with D3. Okay. So the equation of D3 is A into B. The equation of D2 is AB bar. The equation of D1 is A bar B, and equation of D0 A bar B bar. So move to the theory which is given in the virtual lab. The first one is the 2x4 decoder. Now what is the decoder? So the name of the decoder, you can see the name of the decoder means to translate or decode the code. So we have our input as a code, and which is decoder is used to decode the code. Decoder is used to decode the code. Okay. So this is the generalized block diagram of n input and n numbers of output decoder. We have to learn about the 2-line to 4-line decoder. So this is our 2-line to 4-line decoder, which having two input, you can say A and B. So we are using 4 lines. You see here A, B, A bar, B bar, and with having 3 output. You can say Q0, Q1, Q2, and Q3. So when my Q0 is 0, it is its equation is A bar, B bar. For Q1, it is A bar B. Sorry. For Q2, it is AB bar, and for Q3, it is AB. So this is the block diagram of the 2-line to 4-line decoder. So the 2-line to 4-line decoder are generally made by the arrangement of the 4 AND gates, and we are using a 2 NOT gates. So 2-line to 4-line decoder having 2-line to 4-line decoder having 2 inputs and the 4 outputs. 2 input and the 4 output. And this is the truth table of the 2-line to 4-line decoder. You can see here, if my A and B is 0, 0, only Q0 will be activated. If my input is 0, 1, only Q1 input will be activated. If my input is 1, 0, only Q2 input is activated. And suppose my input is 1, 1, only Q3 output will be activated. Only Q3 output will be activated. So this is the block diagram of the 2-line to 4-line decoder. 2-line to 4-line decoder. Okay. Then we have for the move for the encoder. So before moving for the encoder, anyone having any doubt? I think encoder and decoder we already covered in the theory session also. But then also if anyone having any doubt in the decoder, either 3x8 decoder or you can say 2 line to 4 line decoder, you can ask me a question in a chat session or you can ask me a question by unmute yourself. Anyone having any doubt? If you do not have any doubt, please write down a clear in chat session so we move for the encoder. Okay. So now move for the encoder. Again, as we have a multiplexer and demultiplexer which operation or it's opposite to each other, same way we have an encoders and decoders. So the working of the encoders and decoders, or you can say the operation or the performance of the encoders and decoders are the opposite to each other. So you can see here it is already written an encoder is a combination circuit that performs the reverse operation of the decoder. Now what decoder does is it decodes the code. So as the input of the decoder we have a code. But encoder is doing the reverse thing or the reverse operation than the decoder. So in the encoder, the input is the known numbers. You can say decimal numbers or the alphabetic characters. So as the input of the encoder, we have the known numbers like a decimal and alphabetic characters. But it converts that known numbers or the alphabetic characters into a coded form. So it converts that known numbers of a decimal number or you can say octal number or the alphabetic characters a code, into a particular code. So this is the thing of the encoder. So encoder is the device which converts familiar number or a symbol into a coded format actually, into a coded format. So it will do the reverse operation. It will do the reverse operation of compared to the. It will do the reverse operation compared to the decoder. So again, decoder having numbers of input and numbers of output lines. So we have to learn about the 4 line to 2 line in 4 line to 2 line encoder. So in 4 line to 2 line encoder, we have 4 inputs. We have 4 inputs. You can see here Y0, Y1, Y2, and Y3. So we have 4 inputs Y0, Y1, Y2, and Y3, and we have 2 outputs only, A1 and A0. So you can say we have an input decimal number 0, 1, 2, 3. We have a decimal number input 0, 1, 2, 3, and we have to convert this decimal number into binary form. We have to convert those decimal number into a binary form. So suppose my input is 0. Suppose my input is 0. So it converts into a binary. So the binary form is 0, 0. Suppose my input is 1. So it converts that input into a code form. So my code is, you can say 0, 1. For 2, it is 1, 0. For 3, it is 1, 1. Okay. So 0, 0, 0, 1, 1, 0, and 1, 1. So we have 4 different input. You can see in your screen Y0, Y1, Y2, and Y3. And we having a 2 output. You can say A0 and A1. You can say A0 and A1. So this is the truth table of the sorry encoder. So as we have in decoder at a time only one output will be activated. In decoder at a time only one output will be activated. All the other outputs remain inactive. All the others output remain inactive. So in encoder the reverse thing. At a time only one input will be activated. At a time only one input will be activated and all the others input remain, all the others input remain inactive. All the others input remain inactive. So you can see here as an input only Y0 is activated at a time. Only Y0 is activated at a time and the output is 0 0. And the output is 0 0. Then Y1 is activated. Then Y1 is activated and the output is 0 1. Then Y2 is only activated. Then Y2 is only activated and output is A1. Then output is A1 and at the last only Y3 is activated. Only Y3 is activated and the output is 1 1. So what is the difference between encoders and decoders? Let me tell you. In decoder at a time only one output will be activated. The numbers of input are coming together. Okay, wait for the 1 minute. Sorry. So in a decoder at a time only one output will be activated. The inputs are coming together. Inputs are coming together, but in encoder at a time only, in encoder at a time only, in encoder at a time only one input will be activated. The output comes together. Okay, so suppose if you are activated only Y0, then your output will be 0 0. Suppose if you are activated only Y1, then your output will be 0 1. Suppose if you are activated Y2, then your output will be 1 0. And suppose if you are activated 1 Y3, then your output will be 1 1. So this is the thing about the encoders and decoders. This is the thing about the encoders and decoders. So anyone having any doubt in this encoder? If anyone having any doubt, you can ask me a question by unmute yourself. or you can ask me a question in chat session. And if you do not have any doubt, please write down a clear in chat session. Then we will move forward. I didn't get any reply from anyone. Please, if it is clear, please write down a clear. Then we will move forward. So decoder is a device which decode the code. So its input is code, and its output is family and number. An encoder is a device which input is family and number, and it converts into a code, and it's converted into a code. So it is clear for everyone. So let's move for the pre-test. So now you have to give the answer of the pre-test. The first question is, a BCD to 7-segment conversion is a decoding process, encoding process, comparing process, or none of the mentioned. So either it is A, B, C, or D. So give me the answer in a chat session. Again, I am repeating, BCD to 7-segment conversion. So my input is a binary code, and it converts it into a 7-segment conversion. So which process it is? A decoding process, encoding process, comparing process, or none of the mentioned? Okay, so I got the reply from the parts. What about others? Okay, so a reply from the Mahima, Bhavesh, Isa, Jenny, and Parth. So all of you are giving the answer. It is A. Uh, okay, so second one. Invalid BCD. Invalid BCD can be made to a valid BCD by adding with. Suppose if you are remember that BCD addition. If you remember the BCD addition, so we have 6 invalid code in a BCD, which is binary coded decimal. So when we are adding two numbers and the output is invalid BCD code, then we have to add some number. So which number it is? Either 0101, 0110, 0111, 1001. Okay, so I got the reply from the Mahima, Jenny, Parth, and Anand. It is really good because when we are adding two binary numbers, or you can say not binary numbers, two BCD code, and if invalid BCD code is there, then we have to add 6. And if you convert 6 into a binary, then it is 0110. And why 6 only? Because we have a 6 invalid BCD codes. That's why we are adding 6. So very good, everyone. So now the next question is device which converts an input device state into a binary representation of ones or zeros is termed as a, so we have a device which input having some state and it's converting to a binary. It's convert into a binary. So which device it is? Encoder, decoder, multiplexer, or demultiplexer? Okay, so Anand and Parth gives the answer. It is A. Okay, so let me click it. The next question is a circuit that changes a code into a set of signals. So code 2 or some of the signal is code encoder, decoder, multiplexer, or data selector. Okay, so Rajesh gives the answer. It is B. I think Parth gives the answer A. Mahima gives the answer B. Jenny also gives the answer B. So we have an input as a code, and that code convert into some of the signals. So decoder is the device which decodes the code. So in a decoder, the input is code, and it converts into some of the thing. Modulo 6 counters can be built using 3 elements: shift register, bus, flip flop, and trigger. But see, the counters and this all the other things, you can say shift register, bus, flip flop, and trigger. It is not a part of this chapter. This chapter is the combination circuit. It is not a part of that. Okay. Then also Rajesh gives the answer A. Let me click it out. Submit the quiz. Okay. So all the answer is correct. All the answer is correct. So now we have to move for the procedure. So again, we have to connect a supply 5-volt battery. So we have a switch. If you push the switch, the supply will be connected. If you push the switch, the supply will be connected. Then you have to add the buttons of each and every step. So press the switches to select the required input name D0 and D1, and then you have to check the output, which output will be activated. So when your D0 and D1 is 00, your Y0 output must be activated. For 01, Y1, for 10, Y2, and for 11, the Y3 will be activated. Okay. So this is the procedure. This is the procedure for the encoders and the decoders. So let's move for the simulation process. So let me share the link with you. So now you click on the link. You click on the link and start the simulating by yourself. Okay, you click on the link and start the simulating by yourself. So you check here, you have two options. One is for the decoder and another for the encoder. So you click on that. So start the simulation by yourself. I will give you the sorry 10 to 15 minutes. Okay. So now you have a 10 to 15 minutes. Click on the link and start the simulation by yourself. And when you are performing the simulation, if you are facing any doubt, you can ask me a question in a chat session, or you can ask me a question by unmute yourself. Okay. If you are facing any doubt, you can tell me. Then I will open the decoder encoder and we will do the simulation. Okay, so I think almost all of you are already performed the experiment. So let me also show you. If anyone having any doubt, you can ask me a question. It's really easy. Suppose if you are giving the supply, okay, supply is required for the enable the input, but I think no one getting the any issue at that time. Okay, because there is some mistake in this performance. This is a decoder. So when my input is 0 0, when my input is 0 0, the output must be Y0. So my Y0 must be activated, but instead of Y0 here, Y3 will be activated. So I think no one getting doubt. I don't know why. Otherwise, here there is a mistake. Suppose my input is 0 1. So at the 0 1, my Y1 is activated. So sorry, for here it is 1. So here it is 0 1. Okay. For 1 1, my Y0 is activated. You can see here, but instead of Y0, we have to activate it. It must be activated Y3 when my input is 1 1. For 1 0, my input Y2 must be activated, but here it will be Y1. And for 0 1, my Y1 must be activated, but here it is Y0. So there is some error in the there is some error in the decoder. So no one are getting the errors. I don't know why. Okay. If you perform the experiment, then you must aware about that. For 1 1, for 0 0, Y0 is activated. For 0 1, Y1 is activated. For 1 0, Y2 must be activated. And for 1 1, Y3 must be activated. But here the reverse thing is there. Here the reverse thing is there. Okay. So there is a mistake in the simulation of the, there is a mistake in the simulation of the decoder, but no one getting any error. Then let's move for the encoder. Encoder is working perfectly generally. Wait for the 1 minute. So here we do not have to connect a D0. Okay, because when you are giving the supply, when you are not giving anything, your output is 0 0 only. When you are not giving anything, your output is 0 0 only. So just add it to the table. Okay. So when your D1 is 1, your output is 0 1. When your D2 is 1, your output is 1 0, and your D3 is on, your output is 1 1. But if you cannot switch on the two switches together. Okay, you cannot switch on the two switches together. And for 0 0, your output is for D0, your output is 0 0. If you want to start two switches together, you cannot start two switches together. You can see if I am switch on the another switch, the first switch will be automatically off. The first switch will be automatically off. Okay. So this is about the encoders and decoders. This is about the encoders and decoders. So let's move for the post test. So you can see here. So the first question is a decoder converts n inputs to numbers of outputs. N inputs to numbers of outputs. So suppose you have an n input decoder, how many output you have? N raised to n, only n raised to 2, or 2 raised to n. Either it is A, B, C, or D. Okay, that just gives the answer. What about others? Mahima also gives the answer. Okay, so Jenny Rupi gives the answer. So almost all of you are giving the answer. It is 2 raised to n. Again, see BCD to 7 segment question is already comes to the pre-test also. So no need to ask. Okay, the third question, decoders and the encoders are doing reverse operation. Decoders and encoders are doing reverse operation. So option is true, false, maybe, may not be. So either it is A, B, C, or D. Okay, so Rajesh, Mahima, Isa, and Jenny gives the answer that it is A. Okay, let me. Which of the following are the building block of the encoder? Which of the following are the building blocks of the encoder? OR gate, AND gate, NOT gate, or NAND gate? So either it is A, B, C, or D. Okay, Mahima, Rajesh, Jenny gives the answer that it is A. Okay, Isa also gives the answer, it is A. The last one is, which of the following is the decoder IC? Which of the following is the decoder IC? So Rajesh gives the answer, 7890, 8870, 4047, 4041. Okay, so Rajesh, Mahima, Isa, Jenny gives the answer, it is B. Let me click it out. all 5 of 5 questions are correct. Okay, so this is about the encoders and decoders. If you want to learn more about the encoders and decoders, then you click on the references. So there are some reference books, and also there are the links about the encoders and decoders, and there are also a YouTube video of how encoders and decoders will be work, how encoders and decoders will be work. So anyone having any doubt, you can ask me a question. Otherwise, we will end this session. Okay, so uh, let's end the session. I request all of you, please write down your enrollment number for the attendance. And those who already write down their number, if they want to leave, they can leave the meeting.